Alright, so in this video we're going over roots and exponents of polar complex numbers. Now it's easier than it sounds, believe it or not. It is a lot easier than it sounds. So if we wanted to take 2 CIS 35 degrees and we wanted to square it, okay, what exactly would we do? Well, we know that this is the same as writing 2 CIS of 35 degrees times 2 CIS of 35 degrees. All right, and we just went over multiplication of complex numbers, a polar form of complex numbers. So we know that you multiply the r's together, CIS, and then you add the angles together. Well, when you're doing exponents, all you simply have to do, so let's do 2 CIS 35 cubed this time, all you simply have to do is this. You take your r value, whatever it might be, here in this case it's 2, and you raise it to this exponent, and then CIS, you take your angle, and then you multiply it by whatever that exponent is. So this would be 2 cubed, of course, is 8, CIS, and 35 times 3 is 105. So that is literally all there is to using exponents with complex numbers. All right, here, you try this example real quick. We have 3 CIS of 110 raised to the 5th power. So pause the video and work that out real quick. All right, so you should have got 3 to the 5th CIS 110 times 5. All right, so 3 to the 5th power is 243. CIS, and then 110 times 5, well, that's 550. All right, so that's literally all there is to exponents with the polar form of complex numbers. Not too bad. Now let's go over roots. Okay, roots become a little more complicated. Okay, so we know that if we have square roots, such as the square root of 4, we know we're going to have 2 answers, because we're going to have positive and negative 2 for the square root of 4. Okay, and for cube roots, such as the cubed root of 27, we're actually going to have 3 answers. Okay, we're going to have positive 3, okay, but then we're also going to have 2 complex roots. Okay, so you always have as many answers or roots as you do what you're taking, depending on what root you're taking. Like square root, obviously that means 2, so we're going to have 2 roots. Cube root, that means 3, we're going to have 3 roots. Okay, fourth roots, we're going to have 4, and so on. Okay, so now how do we do the root of a complex number? Okay, so how to do roots. All right, so here, you need a little checklist. First of all, if r is negative, okay, if r is negative, you must change r to positive. You must change r to positive. How do we do that? You add 180 degrees to your angle first. Then you take away the negative on r. All right, so the first thing you want to do if r is negative is add 180 degrees, and then you want to take away the negative on r. So that way you have a positive radius, because you want a positive radius. Okay. The next thing you do is you take the nth root of r. Okay, you take the nth root of r, and that will give you a new radius. Okay, so you'll get a new r. Okay, and when I say the nth root, if you're taking the cubed root, you'd take the cubed root of r. Okay, and then you divide the angle by n. So you divide the angle, so theta, by n. Okay, and then this information here actually gives you root number 1. Okay, it actually gives you root number 1. All right, now obviously you're going to need more than one root. So then what you do is you're going to divide 360 degrees by n, okay, and that's going to equal what's called your angle offset. Okay, that's going to give you what's called your angle offset. You're going to add the angle offset, I'm going to call it AO. You're going to add the angle offset to theta, okay, as many times as you need to get your total number of roots that you're looking for. Okay, to get your total number of roots that you're looking for. Let's try an example. All right, let's try an example. I know, because this will be clearer when we actually do an example. So let's find the cubed roots of 8 CIS 120 degrees. All right, so the first thing we're going to do, we're going to check to make sure r is not negative. Okay, so we look, 8 is positive, so we're good there. So now we're going to take the cubed root of 8 to start with. Well, what's the cubed root of 8? That's 2. Okay, so we got the cubed root of 8. Now the next thing we're going to do is we're going to take 120, and since we're trying to find the cubed root, we're going to divide it by 3. Okay, so 120 divided by 3 will give us 40 degrees. All right, that right there is going to be our first root. It's going to be 2 CIS of 40 degrees. Okay, that's our first root. Now we know we need 3 of them, so we have to find 2 more roots. All right, well, they're all going to be 2 CIS. So you can go ahead and copy that straight down. They're all going to be 2 CIS. Then, remember, you want to take 360 and divide it by n. N is 3. So 360 divided by 3 is 120 degrees. All right, this will not always happen, where this angle and your angle offset are the same number. It's just coincidence here. All right, so now what we're going to do is we're going to take and we're going to add 120 degrees to theta as many times as we need to get all our roots. So we're going to take 40 and add 120 degrees, and that's going to give us 160. Then we're going to take the 160, add 120 degrees. That's going to give us 280. All right, so now we have all 3 of our roots. Okay, so all three of these answers are the cubed roots of 8 CIS of 120. All right, so that's all there is to finding the roots. You make sure your r is not negative. If it is, add 180 degrees to your angle and get rid of the negative sign. Then you're going to take whatever root you're looking for of r. So we're looking for the cubed root, so we're going to take the cubed root of r. That is going to be our new radius for all 3 roots, so 2 CIS for all of them. Then you take your angle, divide it by the root you're taking. So we're taking the cubed root, so we're going to divide 120 by 3. That gives us 40. That's your first angle. Then to find your angle offset, you take 360, divide it by 3, because we're looking for the cubed root. That gives you 120. So you add 120 to theta, and you do it again until you have all of your roots. Like if we had 5 roots, we would have done it again, we would have done it again. Of course, it wouldn't have been 120, it would have been 360 divided by 5. But you keep adding until you find all the roots you're looking for. All right? Try this one. Pause the video and find the 4th roots of negative 256 CIS of 80. All right, so the first thing we want to do is we want to look to see if r is negative. Well, r is negative for this case. All right, so what do we want to do? Well, we want to add 180 to our angle and drop the negative. So we're going to have 256 CIS, and then 80 plus 180 is 260. So now we're going to do the same process we did before, but with 256 CIS of 260 degrees. And we had to do that because this was negative, so we had to add 180 to this and lose the negative sign. All right, so now the first thing we're going to do is take the fourth root of 256. Well, the fourth root of 256 is 4. So let's go ahead and start setting this up. 1, 2, 3, 4, because we know we're going to have 4 roots. 4 CIS, 4 CIS. All right, we got all of those set up. Now we're going to take our angle, which was 260, and divide it by 4. 260 divided by 4, and you should have got 65 degrees. That's going to be our first angle, 65 degrees. Now, we need our angle offset. So to get the angle offset, you're going to take 360 divided by 4, because again, we're looking for the fourth root. So we have to divide 360 by 4. When we do that, we get 90 degrees for our angle offset. So now we're going to add 90, and that'll give us 155. We're going to add 90 again, and that'll give us 245. We're going to add 90 again, and that'll give us 335. All right, so those are the 4 roots you should have gotten. 4 CIS of 65, 4 CIS of 155, 4 CIS of 245, and 4 CIS of 335. Okay, so that's all there is to taking the complex roots and taking complex numbers and raising them to exponents. Feel free to watch this video as many times as you need to. Make sure when you come to class tomorrow, you're ready to work some problems. See you tomorrow.